So now I will present the introduction of the project. So the objective is the bridge of the digital divide in undeserved rural Malaysia by deploying scalable fibre optic infrastructure to boost connectivity, economic growth and digital inclusion. Our key component is technical design, access, area or underground fit FTTH deployment, ensuring 5G or IoT readiness. The financial plan, cost-benefit analysis, best cost ratio is 1.5, blended funding, government, PPP and ROI evaluation. Implementation, 24-month phase rollout with risk mitigation. Stakeholder, collaborate with MCMC, ISP and communities for adaptation and literacy program. Then for pilot village, selected based on connectivity gap, population density, 5 until 20 household per kilometer square, economic potential and deployability. Alignment, support Malaysia Jendela or My Digital Goal and UN SDG 9. Justification, public infrastructure project due to high upfront cost, rural focus and alignment with national policies. Our CLO is CL2, engineering economic analysis, cost comparison of installation method using NPV, IRR and payback period. CL3, project management method, Gantt chart development, risk assessment and resource allocation. CL4, evaluation of border application, analysis of socio-economic impact on rural communities. For corporation, for the project breakdown, business 230% growth in connected rural area, healthcare 30% of fewer clinic visit. For student, test score jump to 25% with e-learning. Then our objective is technologies, lay fiber cable in aerial or underground. Money, mixed government grant 70% with private fund. Speed of project, connect 5,000 homes in 24 months. Jobs, train 100 local to maintain it. What we will gain? Economic boom, 44% GDP growth in 5 years. New digital business. Then life-changing service, healthcare 30% fewer clinic trips, education 25% better test score, future-proof tech, fiber last 25 plus years, ready for 5G and IoT service. The challenge is regulatory delay up to 18 months, setback, terrain issue, 100% cost in rocky land, low adaptation, 30% of slower uptake. That's all from me. Thank you.
Now we move to the overview, which is deploy high-speed fiber optic infrastructure in underserved rural communities across Malaysia and support national connectivity goals under Jendela, which is the Salinan Digital Negara. Okay, now we move to the project scope, which is the feasibility studies and site surveys. The second one is the civil works for the construction. The third one is the fiber optic cable installation. The fourth one is the connectivity enlargement to homes and the surrounding place. The fifth one is installation of access point and optical network terminals. The sixth one is training for local technician, and the seventh one is the community engagement and awareness program. So we move to the third one, which is the phase 1 is project discussion and planning within month 1 to the month 3. The phase 2 is the site visit and feasibility study within the months 4 to month 6. And the third one is during the phase 3, the procurement and the pre-deployment setup within the month 7 to month 9. And the phase 4 with infrastructure deployment within the month 10 to month 18. And the phase 5, network activation and community connectivity during the month 19 to the month 21. And the phase 6 is the capacity building and military project manager within month 22 to month 24. And this is the task and responsibility. We have divided the task and the person in charge for each project, which is the project management for project manager, site visit for the network engineer, vendor management to the procurement officer, network activation to the ISP network engineers, infrastructure installation to the civil engineers, the community engagement to the local government organisation. Train and teaching session is technical training facility to help to maintain the facility in our project. And last one is quality monitoring to the auditors. Okay, now this is the timeline schedule that we have converted into the Gantt chart for the whole 30-month duration of project. Okay, this is the budget and resource. We have allocated around RM 12,500,000 total estimated cost for all our costs in our project, and we have divided into a few categories, which is feasibility studies, tools, civil workers, installation and testing, training and practical, project management. We have allocated around 5 million to the tools and fabricables to buy all the expenses, includes ONT, splitters and cable routers. Okay, as for the civil workers, we have allocated around 4.5 million for the trenching, ducting and pole installation. Okay, I think that's all for me. Thank you.
And now we move on to benefits. So for direct benefits, people in rural areas will have faster internet to stream videos and download large files. They will also have education support for students and teachers to conduct online learning, healthcare assistance by no longer needing to travel very far clinics or hospitals, and there will also be more job opportunities during installation and maintenance for the residents. Next are the indirect benefits, where people in rural areas will experience economic growth with the rising use of technology for businesses, emergency communication for authorities to issue orders in case of emergencies. People in rural areas can also be socially included by communicating with distant loved ones. And last but not least, digital equality, where there will be little difference between people in rural and urban areas. For these benefits, this project requires skilled technicians to perform maintenance in hard-to-reach places. Low usage risk leads to slow return on investment and risks of infrastructures being underused. The environment will also be damaged from digging activities, thus affecting nature and ecosystems. And lastly, high setup cost due to expensive materials to obtain and difficult places to navigate installation. The BCR calculations, we use these parameters and these formulas. Our target is to exceed the BCR of 1.50, and we managed to achieve it by plugging the parameters into these equations. In the end, we managed to receive a BCR of 1.53. And now for the incremental BC analysis, the first step is to create an alternative project that is smaller scale and label it alternative A. And then we compare it with our project, which we label alternative B. To find alternative A's annual benefits, we can obtain a scaling factor by having the ratio of alternative B's B and C without the present work. And then we multiply that scaling factor with alternative A's cost. After that, we plug in the values into the equation and we receive the BCR of 1.53. This means that for the extra investment to upgrade into our project, we make 1 ringgit 53 cents for every 1 ringgit spent on the extra investment. Move on to the implications. Under organization, we have operational impact where we manage to integrate fiber network systems. Resource allocation, especially on budget planning and outsourcing services. Workforce development, which we reinforce with skilled technicians and engineers. Strategic impact where we stand out as the tech enabler of rural areas. Next is societal implications. For digital inclusion, we reduce the digital divide between rural and urban areas. Education and skills where students can better access research materials and online education. Healthcare access with the introduction of telemedicine services. Economic development for rural entrepreneurs and farmers to engage in e-commerce. Social connectivity where we improve communication on long-distance relationships. And last but not least, government and public services for citizens in rural areas to access welfare apps and disaster response for citizen coordination.
Next, I'll briefly cover how we are managing resources and scheduling for our project. To start off, let's take a look at our project planning progress. So the flow is first we decide our project definition and baseline, then we specify our core planning, which consists of schedule, resources, and cost baseline. Next, risk and spotting plans connecting all the baseline, and finally, the endpoint, the master plan. Next, our project faces various constraints. These can be technical, such as needing to finalize the network design before we can procure materials or secure permits before groundwork. We also encounter physical constraints stemming from variable conditions like unpredictable weather, challenging terrain, and many more. And finally, and crucially, we have resource constraints primarily related to the availability of skilled labor, like our civil engineers contracted and fiber technicians, as well as specialized material and equipment. Given these challenges, we conducted a priority matrix and our project is classified as resource and performance constraint. To manage these constraints, our resource allocation plan focuses on strategically deploying our limited civil engineers and fiber technicians team. We are scheduling heretics like prioritizing tasks with minimum slacks and smallest durations through a parallel method. The direct implementation on our project schedule is quite significant. While we initially planned for 24 months, our realistic resource constraint schedule extends the project duration to 28 months. This extension occurs because activities that could ideally run in parallel, like trenching and pole installation and phase swap, now become sequential to share limited teams. All in all, this part highlights how crucial effective resource allocation and scheduling are important in ensuring a project success.
In conclusion, a rural fiber optic installation project is a vital step toward digital equity in Malaysia. Economically viable with a benefit cost ratio of 1.453, it uses a cost-effective mix of aerial and underground method. Technically, its features ready with GPON based FTTH and local technician training. Socially, it boosts healthcare, education and job access for the 5,000 rural households. Backed by national policy and eco-conscious design, this project is both feasible and urgent. In conclusion, this is more than infrastructure. It is called to bridge the digital divide and build a connected, inclusive future. That's all from us. Thank you.